Hello, my name is Sonja Jähnig. I'm a freshwater ecologist. I'm leading a research group at the Leibniz Institute of Freshwater Ecology and Inland Fisheries in Berlin, and I'm a professor of aquatic ecogeography at the Humboldt-Universität zu Berlin. When the wall fell, I was still a teenage kid, so I don't have a distinct memory of that very night. But shortly afterwards, we went in the car and visited our relatives in Eastern Germany, and I very much remember that joyful disbelief that all the stressful border controls had ceased. We had a veterinarian in our family, and for some reason this doctor raised a female lion in his garage. Her name was Paka. And as a child, I really wanted to become a veterinarian as well. I think now it was more about the lion, and you can see that this wish did not become true, but I'm still engaged in caring for large animals today. Inland waters are rivers, streams, wetlands, and lakes. They cover less than 1% of the Earth's surface, but provide habitat to over 30% of the vertebrate species. Freshwater ecosystems provide multiple ecosystem services to humans, for example, drinking water, irrigation for agriculture, or recreational opportunities. But freshwater biodiversity is under tremendous stress. Vertebrate populations have declined by 84% in the last 50 years. However, this dramatic situation is rarely in the focus of public attention or action. It is a truly silent crisis. This is the wall my research breaks, pushing the silent freshwater biodiversity crisis on the political and social agenda. I believe that my study objects, freshwater megafauna, can make this happen. These are impressively large, often iconic species that can grow my height or many times my height and my weight. They can grow as old as humans and have fascinating life cycles. For example, beavers, giant fish like sturgeon or catfish, mammals like hippos, or river dolphins and even salamanders belong to this group. As flagship species, they can help raising awareness, and protecting them will simultaneously ensure protection of many other species and freshwater ecosystems. Besides defining and coining the term freshwater megafauna, we have compiled a massive data set. And one of our most important data analyses shows that freshwater fish, large freshwater fish, have declined by 94% since 1970. Now we can make use of data combinations, for example, explaining conflicts between freshwater biodiversity and other uses of the ecosystem. For example, building of hydropower dam is often perceived as a green energy source. However, it will have detrimental effects for megafauna species, for example, by blocking migratory routes to spawning or feeding grounds. So I'm assuming that my research will lead to an improved conservation of freshwater biodiversity. Managing freshwater biodiversity in a sustainable way can be as fundamental as to sustain your livelihood. Over 150 million people on the world depend on freshwater fish as their main resource of protein. Other benefits relate to health aspects and human well-being. We can assume that over 50% of freshwater megafauna species are threatened. But there are many reasons to expect that they are not easily replaceable in the ecosystems, considering what we know about their ecological roles. So what will happen to the stability of ecosystems, to the functions provided when freshwater megafauna species disappear from ecosystems? My 8-year-old daughter knows that I work in freshwater ecosystems, and I think it's really great that she knows that there's a lot of life below the water surface.